And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop. I think I've been rather hard on Peak Electronics. If you remember, a few weeks ago we did the little 11-inch Colster Brands TV set, and we thought there might be some problems with the transistors in our UHF tuner. So we replaced them and eventually solved the problem. Although we don't think it was this, but I'm going to come back to this because at the time I called into question whether the DCA was correctly identifying the germanium transistor. So this transistor here, this was the front end, and this is the mixer. So I'm just going to push the analyze button. I'm hoping you can see that. The DCA has correctly identified a PNP germanium transistor. So, interesting. Now, if I hook up the tester to the front end transistor, there we go, hit the test button. Takes a long time. Common anode diode network, which is what we saw before. Now if you think about a PNP transistor, it is a common anode diode network, but obviously this one therefore doesn't have any gain, and also forward volts for D1 1.31 volts. It seems very high. I wonder if this thing just hasn't got any gain anymore. You know, it got cooked and that's the end of it. I've also got a brand new BF239 there, which incidentally tests okay as well. Anyway, because I called into question the DCA, I really don't think I should have done. Anyway, I went ahead and bought myself this thing on AliExpress for very little money. Purports to be a component tester. So anyway, I thought, well, another piece of testing, it might make it an interesting video, mightn't it? So here it is. What have we got? We've got a board of readily assembled electronics and into what looks like a static sensitive bag as well. And we've also got some cut pieces of acrylic, which I'm presuming we assemble into the case. Yeah. Oh, it's not acrylic. Is it acrylic? Yes, it is. It's clear. It's just, I thought it was some sort of fiberboard then for a moment. So let's see if we can't, of course with these things there's never any blasted instructions, is there? So let's try and see how it all sort of fits together. And yeah, there we go. So we've got a board with a 9-volt battery clip, bit of tape around it, an LCD display. Looks quite nicely made, doesn't it, really? This was very little money. This was a little over £11 delivered to the UK, so... Oh, peeling. Lovely. So there it is. So I wonder how it all sort of fits together in the case. Oh, that's obviously that way around, isn't it? So, alright, I wonder if that... Why would we need access to the rear? Battery? Or maybe the battery sort of goes like that. Yep, that's sort of to hold the battery in, isn't it? So, oh, we've got some holes there. That's obviously what these standoffs are for. These screws seem awfully long, don't they? Perhaps it just wedges in between. All a bit of a mystery. So, what do we think? So we've got 4 standoffs. Are they for there? or are they? That would presumably sit in like that, so that's obviously got a cutout in it for the lever for the ZIF socket. So does it sort of go together like that, do we think? I'll peel the peely bits off in a minute. And I've got a hole there for some reason. I don't know what that one's for. So that obviously sits in like that. Why would I need access to that? I don't think I will, but hey, let's just snip it together and see what happens. Then that obviously fits on the top. So that's obviously what our long screws are for. Yep. Okay, so these shorts, not only that, but there's obviously no standoff in there, so the standoff is just for the board. Right, I think we know where we're going. Have they given me enough of the shorter screws to put the board together? Let's do the peeling. Because you know I'm always enamoured about how long it takes me to peel anything off. At last. Right. So what do we got? I think it sort of goes together a bit like this. That is going to go that way because it's got the notch in it for the ZIF socket lever. That's going to go in there. I still don't know what that's for. Ah, 2 pins there maybe? Maybe a programming socket of some description was originally envisaged, but there we are. Don't think it's needed now, so we want 4 shorter screws. I'm going to pop those through from the bottom, I think. Oh, well, let's leave that frame bit till last, shall we? Oh, come here. Three, 4 shorter screws. Come on. Oh, it's a little bit fiddly, isn't it? Bingo. 4 of the little standoffs. One PCB. I'm just going to want the 9 volts running on the inside like that. Inside. That's it. Okay. And 4 nuts. Right, where's my M3 nut spinner? There it is. I think they're M3. Yep. And I'm out of shot as usual. Can't get that on that one because of the display. That one's all right. Yeah, I can. Just good in there. Right, that's that. So put some sides on it. That's the bit where the ZIF socket goes that way. That's it. We'll need a little 9-volt battery. A GP green cell. Well, to point out, by the way, I'm not sponsored by anybody. This I have bought with my own money for my own uses, so you'll get an honest review of it in minutes few. Right, let's just attach the battery snap. Lights up. Test is M-Tester. Testing. No unknown or damaged part. Yeah, I'll buy that. We haven't got anything plugged in. Right, that then fits... no, it doesn't fit like that. It fits like that. Oh, that's quite smart. Put the long screws in the corners. I wonder if it ever switches itself off. Oh, that cutout's there's for the surface mount, whatever that is, in there. Quite sure what that's for, but hey. 4 more nuts. What's the microprocessor while we're looking at it? It's an Atmel of some description. Right, what is that? It is an Atmel Mega 328. There you go. It's an Arduino, really. There we go. Right, so first things first. You can see here this socket is numbered 123111. So I'm thinking that the first 3 legs are connected to the test points and the others are just not, so to speak. So let's get an ordinary transistor of some description. Just put those out of the way. Oh, and just push it in there and see what happens. So I have no idea what this is. It is a P-channel power MOSFET. So let's put that in there, see what it says. M-Tester testing. You can't see that because of the glare. Let's turn the lighting down a bit. It is an NEMOS. So, yeah, it's worked beautifully. Nice clear display too. Look at that. That's really very good. Okay, so now sadly I need to fit my germanium transistor in there. I've got one here that's yeah, it's a brand new one, so let's just put that in. Obviously the ones I've got 2 shorter legs, but I have a solution for that in a minute. Right, push that in there and see what happens. M-Tester testing. It's a diode. I suspect I've got that in wrong. This is all very strange. One of these legs will be connected to the can, I think. So let's see which one that is and then measure it again. Ah, that one. Okay. That's the screen. So that should measure the transistor. It might, of course, be duff. I don't think it is, but it's a PNP transistor, so it's got that right. So just like our DCA, it's identified that as a transistor. It's given us an HFE of 476 and 504 millivolts junction. Right, now the problem is now, of course, I can't measure these transistors because, well, I haven't got any leads. So what I'm just going to do is, I think I'll make up a little set of micro hooks. Got a bag of micro hooks here, so why wouldn't we? Let's go blue, green and yellow, shall we? For no adequately explained reason. Put a bit of wire on that and just drop it straight into the socket, and then I can hook on, same as the DCA. Right, let's find a suitable bit of wire. I'll just strip 3 bits out of this ribbon, maybe. That's going to be super long enough, isn't it? Okay, so that's how these sort of micro hooks work. They're not the highest quality in the world, but they are only about 30p each, so it's adequate for our purposes. Just going to tin that up, insert it through the slot in the cap. Oops. Right. Insert that through the slot in the cap like that. There we are. Comes through, and we just want to solder it through the contact here. Mine shot, just about. Oh, where is the blob of workshop blue tack gone? It was here a moment ago. Treat yourself to a new bit. The universal vice. Let's use the whole lot. Look how shiny colour the new piece is compared with our old bit. Right. Perfect. And then the hook part slides up the inside here. It goes together. Push it together a couple of times just so it seats. Ideal. Right, rinse and repeat. There we go. Right, so that's our 3 probes connected there. So I'm just going to put these into the first 3 sockets, 3 holes rather, on our ZIF socket. Could solder a bit of header on there, couldn't I? It would make quite a tidy job of that. May do that in a moment. A few, but right for now, that will prove our point. Oh, go on. You know you want to. So this is the one the DCA passes, which was the local oscillator. So let's see what this analyzer makes of it. One, 2, 3. Off we go. We're testing. We'll turn that down. And yeah, correctly identifies it as a PNP transistor. You see that on the camera? Let's have a little zoom in. You really can't see that on that camera at all, can you? There we go. PNP transistor, nice little display. HFE of 471, UF of 510 millivolts. That's interesting because with the DCA, it refused to give us an HFE reading because it said there was a resistor between the base and emitter, which is probably just a little bit of leakage. It is a germanium transistor after all. Right, now this is the one DCA said was a common anode diode network. So let's zoom out so you can see what I'm doing again. There we go. All right. So let's hook this one up and see what it rates it at this time. Right, let's go. Testing. Will you look at that PNP transistor? Can you see? There we go. Oh, I over-egged it as usual, haven't I? There we go. PNP transistor. So junction voltage 511 millivolts, HFE 537. I think our DCA has been lying to us about these two transistors, which is interesting. I'd always suspected it, but here we are with this AliExpress M-Tester component tester. All right, and it's taken me far too long to peel the plastic stuff off it. But what a useful little tool. Is it going to be reliable? Am I going to be able to trust it? Time will tell. I suspect I'm going to get on very well with it. It's a super easy to read display. I'm pleased as punch with that. Reasonable looking case. Switches itself off. Don't know what the battery life's going to be, but yeah, there it is. And, you know, not a serious amount of money for a very useful little test instrument. Well, there you go. That sort of concludes this this part of Doz's television workshop. So yeah, thanks for watching as usual, and click like, subscribe, do all that, and I shall see you really soon here on Doz's television workshop. Bye. That'll be Darren come to collect some capacitors.